Hello, everybody. How y'all doing tonight? So tonight, oh, Soraya was there for a second. Must be a bad internet connection. So tonight is the second lecture of Module 4. It's pretty much halfway. I guess technically it's not halfway until the homework for Module 4 is due next Monday. But the 8-week terms, that's halfway to halfway. Halfway through our course, things moving along. Hopefully it's all going well. It really helps that everybody's seen Python before, so then we can do more interesting things that we usually can't do in the other classes because we're looking at a new language. Again, the 200 class have to spend a bunch of time introducing Java and the tools available in Java, and that takes away from the higher level stuff we can do in Java. But having seen Python before, one of the things that we can go ahead and take for granted that y'all know some of the basic Python and get to more interesting things. So we're going to look at APIs tonight. First off, I want to continue that data storage. Tonight, the continuation on it is going to be storage/transfer. So we want to transfer our files, the format to transfer it. Compatibility is a big deal, right? We're not developing software in a vacuum. There's other software that's out there, software that wasn't developed by us. I'm sure everybody's been annoyed by how Apple does that at least once in their lives, right? Apple acts like they're the only ones that develop software, so their stuff doesn't work so well with non-Apple software. It seems frustrating in our modern world. But there are some standards. One that we're going to use a lot, which in the videos that I put up, I didn't like the way they described it. They were talking about it like personal preference. JSON is what we're going to use the most. It's easy to work with. The reason we use it the most is we're transferring across the network. The most likely place that's going to be processed is on a browser. That's how we access things across the network, which there is a standard for that. So on that browser, it will be processed in JavaScript. So JSON is actually a JavaScript object. We're sending a JavaScript object. If we're only sending values, so if we're just sending some numbers and sending some strings, that's fine. But what if we need to send a function? A Python dictionary and JSON, if you were just to look at both of them side by side, if you just have like some numbers in there and some strings and some basic data, you couldn't tell the difference between them. They handle functions differently though. If we have a Python function and wanted to send that to the client to run, we need to turn it from Python code into Java code, or sorry, JavaScript code. So that would be a difference. Yes, Tiff.
Can you mute your laptop? Because we hear a little echo from it.
My laptop is muted. Is somebody else's laptop unmuted? I do not have audio connected.
Okay.
Does one of y'all have audio connected? That might be on your end, Tiff, because the three of us in the classroom do not have the audio connected. Oh, I could have looked up at the list. There's no microphone pictures by any of our names. Sorry. If it continues, let me know. I'm not sure what it would be causing it, but it might be on your side. But JSON is in both of those videos that are related to the APIs and the homeworks, just to follow along those and make something very similar. You're going to do books instead of soft drinks, or our example in class tonight is going to be people, the one we started the other day. They talk about it as they say JSON is a text file. It's not a text file, it's a JavaScript object. That's one of the reasons we send it that way. It's in the right form. And a lot of times it comes down to personal preference how we send it. JSON is easy to work with. XML is not bad to work with. And generally, the computer is going to write the XML tags or take our data and turn it into JSON data. So we're not typing either one. So they're completely interchangeable as far as we go, because we're not typing those tags for markup. And we're not typing we're not typing out the dictionary for the JSON. So we don't really have extra work, except maybe when we set up a function the very first time. The reason you would want to use different ones, the reason JSON is the most popular is because that it's most likely going to be processed by JavaScript or Python on the other side. And those are both open type languages. If we're going to a strictly typed language, so if we're sending it somewhere that we know is going to be processed by Java or C++, Texas TI chips, Texas Instruments, I don't know, an MSP 340, those are great little microcontroller chips, reprogrammable microcontroller chips, great for home automation, but they have to be coded in C++, which means if we send data to a smart home, it's going to be processed in C++. And there JSON becomes a problem because JSON's an open type. JSON's JavaScript, which is an open type language. But with a markup language, we can include the type data. So then because on C++, we have to say, before we can do anything with that data, we have to say whether it's an integer or a string, actually we're not strings, an integer, a character, array of characters, a floating point number. We have to say all that stuff before we can even begin to work with it. So when we don't have that information in the data, which is what a JSON format would have, there's a lot of extra overhead necessary to do that. And embedded systems are a great example of that, because embedded systems are most often going to be written, or quite often written with C++ still. And it's an embedded system. It's not a big, powerful computer. It's a small thing, so we don't have a lot of room for tons of overhead. So really, where it's going. But then other times, I guess it's still where it's going. Time I use XML most often is when the data is going directly to the web page. So sometimes I'll put HTML there, just put it in HTML tags and send it, but I'll just include the XML tags in the style sheet and go ahead and include some tag selectors in the style sheet for the XML that I know is in the database. Then I just send that XML and look right up there, and it bleeds right into the HTML code. And there's no processing done whatsoever. That means it needs to go to a markup language to get on the web page. And we don't need to do any of the fancy JavaScript stuff. So in that case, at least I like to send the markup language in that case, which I guess that's still with the usage. Other times it's personal preference. What sort of thing do you like using? Markup languages are better for a machine. JSON, the O is the object. It's object-oriented programming. Object-oriented is good for the human, terrible for the machine. Markup languages are a nice middle ground where it's human readable, but it's closer to the format that the machine actually does, as far as like CPU, RAM, registers, going through accumulators and ALUs. Markup languages are closer to that and still in human readable form. So when it gets big, and then the third one I was going to look at is CSV, which is just comma separated values. It is a pure text file with delimiters so the computer can jump around in it like a database. But it doesn't have any overhead whatsoever. Markup languages and JSON both have lots of overhead in them. JSON has a lot more than the markup language. But CSV has no extra stuff whatsoever. So in a classroom, anything we do here in class it's not going to matter at all, right? But we got a database with 500 million data points that had data about 500 million people. That's pretty small for the modern world, right? That's tiny for a modern database. But if we save, if the format for transmitting is only 1/4 the size of the other ones, that's a big difference there. So that's a common one for transfer of big data sets. So then we have less to transfer because all that overhead also means more bits that have to be transferred. Let's see, what else did I get? So we'll look at those three. which are near standard. Everybody's heard of those before,
What
right?
does CSV
You
stand
probably heard of
for?
CSV before you ever took your first IT course. XML and JSON are very common. JSON is probably the most popular, but it's not an arbitrary text thing. The reason is because we're probably going to process it in JavaScript or Python. So we send it in a file that's good for processing. Then we'll look at APIs, which is interface thing. We talked about interface the other day. We'll talk about it more. Also put a note here, optimal. You'll have more time when you're doing the homework. Some of you might have more time. I understand how schedules go. Some of y'all might have more time when you're doing the homework than we have in our class example here. So the optimal way to do this would be to store the data for your program in SQLite. So you get a relational database. To work with the data, you filter it in storage before bringing it to RAM. So it's a lot more efficient as far as what that processing is doing. And then turn what you get from the SQLite database into JSON and send that. Which we're getting ready to look at is just the word JSON.dump. So that's not a complicated process, but we saw one part of that the other day, and we're going to see another part of it tonight. So we've seen both parts, and we are very restricted for time in lecture. But when you do your homework, there's probably time to do them both at once. If you watch that Flask video, please don't use that library he used. That's not a very good library. It prints out a warning that says it's not a good library. It's in the slowest language we have, and it actually includes an extra warning talking about how slow it is. It's like, that's a bad sign. It might work it would probably be okay for your homework, but there's only like 5 data points in the set, but it's not going to work for anything feasible. So you might as well practice one that you know you're actually going to use. SQLite can handle millions of data points without problem, assuming you have a big enough hard drive. SQLite, it's a SQL database, so the limitations are the size of your hard drive. We don't need the data to process it. We need the relationships between the data, and those are very, very small. We talked about that the other day, though, so we need to look at the other points. Let's jump right into the examples here. Excuse me, I better take a cough drop. It started sprinkling just a little, and I started coughing like crazy all afternoon. So probably going to have a cough drop in my mouth all week. That time of year, I guess.
Yep.
All right, hopefully that'll help. Okay, so while Spider's opening, we also need the files from the other day, which I deleted from the other day because there's something we haven't looked at yet. The files from the other day are up on GitHub. So we saw going to the browser, hitting that green button, download the zip file, moving that around. We saw the Git GUI. Personally, I think the best advantage of the Git GUI is that the history is, looking at the history of the repository is best in Git GUI. That's the best interface. That's the best way to interface with the history of the repository and get back to any time along the way. Like, unless you send me a note and says I forgot about something, when I grade those, I do roll back to the submission time. So if you do stuff afterwards, like if you go ahead and jump start on the next homework assignment when I start grading, I won't see it when I download the repository because I'm downloading I'm downloading the repository from 11:59 on the due date. Although sometimes such happens. I've gotten a couple emails where it's like, oh, I forgot to do this and did this like a day later or something. And it's before I got around to grading, so it's still okay with that. But there's also terminal applications. And speaking of terminals, we'll see it soon, a little bit better soon, but they did set up some Linux machines. If y'all weren't aware, you probably encountered that most programmers tend to work on, most of the professional level programmers tend to work on Linux machines, or at least something .nix. A lot of them go with Mac, just that they want that they want the Unix part of Mac, not the Mac part of Mac. There's reasons programmers do that. So they set up some virtual machines in here that can be remotely accessed. You have to remote into remotely access the computer lab, but then on this network, there's some IP addresses. We'll see that soon with some Linux machines that y'all can use if you don't have a Linux machine or don't have one convenient to work with yourself, because you might want to see it, or at the very least, you might want to test your software on that. But I mentioned that because we do a lot of stuff in Linux in the terminal. We don't do as much in on Windows in the terminal usually. But anytime we click an icon in Windows, all it does is run an instruction in the terminal in the background. Run an instruction that's already built. So we can ask for those same instructions here. And as programmers, we often will have to. We'll need to automate them. We'll need to automate those instructions, not just click the icons. So right now we need to get the GitHub stuff. So we haven't looked at this one yet. So I'm going to navigate over to my working directory, go to documents and delete, clear all this out. And the only thing in there is the file from this afternoon's class. That doesn't have it's not going to help us in Python. So I'm going to make a folder to put it in. So make a directory and I'll just call it Git stuff. That works. And if you wanted to, you could do everything else from this level. But personally, I like to navigate into the folder I'm actually working in. So I'm going to go into that folder I just created, which right now is empty. There's nothing in there. Need to set it up to be a repository, because a repository isn't just storage, right? If all we needed was online storage, we could use Google Drive or something. We didn't need to go through the extra steps for GitHub. But if we type in here git and init for initialize, and then dot. Since dot refers to the folder we're in, most of y'all have probably seen dot slash. So dot for the current folder, then a second dot for the parent, and the slash to go into that folder. So dot is our current folder. So I'm going to initialize this for git. I'll list that out. Oh, it's not showing there. If I come over here, there's our folder, and hidden things are turned on, so you can see it added some stuff. 23.4 kilobytes of files with a whole bunch of folders and configs and other things built in right in there. So that's ready to be a repository now. So to grab the one for our class here, I want to remotely access the online one. So git remote and add the origin of this repository. Right, this repository is stored on a server somewhere else in the world, probably Vancouver, British Columbia. That's not anything you would ever need to know. That's just where most of the GitHub stuff is stored. The home base of where Azure the home base of all of Azure main servers, but they're also scattered all over the world. So it could be half of it's in British Columbia and half of it's in Australia. But doesn't matter where it's stored. We need to connect it. So the origin, we need to add a new origin for this repository, and that's going to be the address. Just the way regular web connection. Trying to say too many things there at once. The way we connect to it on the web, https://github.com, and then I happen to know my account's Francis-Chris5, and this is SDEV 220-spring 2023. And when we type it in here, I ran out of room and these pictures are in the way for people watching the TV up there. Get those out of the way. Make this just a little bit wider so I can keep typing. Then there at the end, we want .git. So make sure you do the .git extension. No error message counts as a confirmation. One of those situations. I guess I could have made that smaller and fit it on there nicely as well too, when word wrap kicked in. But git remote, add an origin for the repository. Then the URL to where you would normally go to in the browser, and just make sure you do the .git extension. And all of that right there, if you go to the web, GitHub on the web, and when you hit that Git code button, the green button, there's different options. One of them has a URL with copy and paste. The copy and paste that's what the copy and paste has with the extension and everything. So now that I've initialized that folder to be a repository and connected to an origin somewhere, I can pull those down. So Git pull that particular origin, and I want to pull the main branch, which remember we had some stuff where I forgot to change the name earlier. So there's a main and a master branch. And I can't get rid of both of them. I haven't gone back and do it. So I'll just work on the main branch. Anything else I'll do will probably be in the terminal, do it this way. So we're going to pull down the main branch off that origin. Which will grab all that code. And this is what I do when I grade your homework. With a couple other parameters to define which, what time to, to go back to the timestamp of the due date. So now that we have those, if I list that out, we can see that we have all the stuff from that repository here. One for the class is very disorganized. I don't think there's many files at all. I did put the stuff the other day in a file, didn't I? Yeah, data storage and API got its own folder. So we're done here for now. I'm going to close out the terminal and come back over to Spider and open the stuff here. So let's go into File Explorer, Documents, delete. Here's that GitHub stuff and data storage and API. So here's the ones we had the other day. In this class. So this is our data example, just a simple data class, just a few data fields, which again, it is the opposite of a coincidence that we use the same term as we do in databases. They look very different in a text file, but a text file is not what goes to the CPU and RAM and registers and ALU and all of that stuff. Right? So in a text file, they look very different, but they have the same name. And as far as the computer is concerned, they're the same when we get to processing them. Another reason that relational databases are the better one to use. But a relational database is local, right? Our SQLite database is local. That was simple storage. So we looked at binary code. Like if it's data just for our program, let's keep it in Python format. We have that binary format that Python works with that list of data in. So why even change that? Let's just throw it in a file in that format. And then when we get it back, we'll just bring it back in, and then we don't have to worry about any changes or anything. A human doesn't need to read that. When our data set, that works, when our data set gets large, or if we want to filter it along the way, it's best to use relational database properties or non-relational database properties. We can do that as well. But if you know NoSQL databases, it's the obvious extension on that. We'll look at the SQL ones here. But it's best to use this because this filters it as it comes from storage. So we might have 500 million data points over in storage, but we only need 30 data points. And from our select query, the way we grab it from storage, we can make sure that only those 30 data points come over to RAM. So then those resources are still available. Multi-threading, parallel processing. No, it's not just our software, right? If I come over here and start up the task manager, there's way more than just my piece of software running right now. It takes a minute to scroll through the list of all the software that's running. So any RAM that we are not using, or anything in CPU or memory on that list that we are not using, could be used by something else. And that's pretty consistent for any machine we're running on. Okay. Our software might be great, but if our software messes up everything else on the user's computer, they're not going to be happy. It's not going to take them long to make that connection that it's our software messing up everything else going on their computer. So there is still some reason to concern ourselves with efficiency and stuff. But that's storage, not quite to transfer yet. I guess for the next file, I'll create a new file. Because we can also store it, but we're getting ready to get into APIs here in a few minutes. So we know transferring and compatibility with other software is going to be an issue. So why don't we just store it in that format? Store it as an XML file, or store it as CSV, or store it as JSON. It's kind of the same thing as that pickling. That's the format we need it in, so let's just store it in that format and not bother with any human readability or anything. If we know we're going to be transferring JSON across the internet, let's just store it as a JSON file. And then when we go to make our API, we just grab that file and do that. The downside of that is it is a flat file. It's a file. We need if we want to see that in our program, we have to bring that entire file into RAM. And data sets can easily grow to a size that the entire file is not going to fit in RAM at once. So again, the optimal way to do this, because this is what you would do in the real world on your homework, we don't have a lot of time in class, is set up your program to store with an SQLite database. And eventually when you have GUIs and stuff, then control the select query from a GUI to choose just the data you want. And then when you get that over in your Python program, just throw it in JSON format and send it. That would be the industry standard for our modern world. You'd probably go over to like a MySQL or MongoDB, one of the big ones. I really like OrientDB for non-relational stuff. I looked at a whole bunch of them. That's the one closest to the DBMS 110 class. And as I learned about that to share with students, I really started to like it myself. There's a major company that uses it to deliver 400,000 targeted ads per second. That's a lot of data to go through. Because it's not the 400,000 people it's not the same 400,000 people every second. So we're talking big company there, right? So let's look at those other formats.
Is OrientDB SQL or no SQL?
It's no SQL. It's node-based. It's node-based, so it's no SQL, but a lot of times people will refer to JSON flat files as NoSQL databases. But they're a flat file. We need the whole file every time. AWS is bad about that. The official AWS one is a giant flat file, which isn't the same as a non-relational database. I'll show it to you sometime, Tiff, and introduce you to it. I'll try to work it in class. We should have time for odds and ends at the end. It's fairly easy to use. Oh, actually, they were the first one I saw that did it. If y'all haven't seen this elsewhere, OrientDB was the first one I saw that did it. But there's a Udemy course embedded in the official documentation. I thought that was the greatest idea I'd ever seen when I first saw that. I was like, oh, that's going to be everywhere soon. The tutorial.
They have so OrientDB
are built right into it.
OrientDB has a Udemy course embedded in it.
In the documentation. So that makes it really easy to learn too. It's right there in the official documentation. You go to the website and there's a Udemy course right there, right beside all the normal documentation stuff we would see, like the keywords and what they mean. But we'll look at that sometime later. We need to get on topic. So our three main forms, XML, JSON, CSV, personal preference, there are reasons why we would use each one. Talked about those earlier, but it's mostly going to be JSON in the modern world, but there are reasons to use the other ones. So I want to show them to you because they're not much trouble to use at all. I should open my example for, oh, whoops, that's not it. Open it from last spring when I taught the class. That way I don't get too off track. I'm going to go ahead and save this so I don't forget to later. And this one, so simple storage, I'm going to call transfer and store. or store and transfer or something like that. Same way as doing, because again, just like that pickling, if we know we're going to be sending XML files, we might as well just use that for our storage too. So we can grab it, filter it, send it, and we don't have to waste time changing the format. So better set up a data set, and I'm just going to copy over the data set from the other day. There we go. There's a nice little data set. Copy, as long as I remember that that list is called folks. I seem to keep forgetting it the other day. Let's start with CSV. That's really easy. Spreadsheets grew out of CSV. If you weren't aware of that, CSV files have been around for a long time. Comma separated values, comma separated variables is what it originally stood for. Sometimes those change, kind of like HSL, which the color was originally used, saturation and luminosity, and over the years we were like, nobody uses the word luminosity, so that eventually became lightness, and you'll see light if you even Google it these days, because nobody uses that word. Same thing with the comma separated variables. Only programmers use variables, so it started to be, people started saying value. Non-programmers started saying value, and programmers are fine with that word. So what the acronym stands for is kind of changed over the years. Had some white space because, well, for the scrolling issue. That'll work. So, well, for all of these, we have a library. I'm just going to import CSV, but if you all prefer the from CSV, import something, import asterisks, that, or import the particular ones, that's fine. I just like to do this for the class examples. In my own code, I almost always use the from CSV import something. And that's something that's almost always the wildcard selector. Okay, it's in this module from CSV import everything. But for class examples, it's just a lot clearer what comes from that module if I do it this way. And it's similar to a file. So that library has basically everything we need. With open, I think we're up to 3, data file 3, and this one's going to be a CSV file. And we're going to open it for writing. Spreadsheets grew out of CSVs, so it is human readable form. A spreadsheet is a CSV with nice little graphics put on it. Is the origin of a spreadsheet. Is to file. I guess we should write it first before we have to write it before we read it. And we have little objects we can work with. So there's a CSV writer. I'll just call it writer. It's going to be csv.writer. And it needs to know what file handler to work with. In class examples, well, I shouldn't call that to file because there's going to be different ones. I'm going to call this CSV handler. That's like a variable. That's just a reference value, right? It just refers to the handler we created. In your previous class, you would have seen something like CSV handler equals the open method. This is generally the preferred way to do it in Python with the with keyword. With this file handler as this name, do all of this stuff. The previous class kind of generalizes things. It's also a good example of how there's more than one way to use these tools. Polymorphism, multiple uses for the same tool. I guess this isn't really polymorphism, that's just a different syntax, but there's more than one way to write our code with the same tools. So we need the handler. So we have that CSV handler, which isn't a very good one because that's really close to my initials, and I'm probably going to keep typing my initials. If anybody sees an F show up there, let me know. I'm much more used to typing my initials. Now we can just walk through our list. So for F in folks, I remember that time. Writer write row. So the first thing about it is the CSV works with a list. we need to send it list. So we can't, actually, I'll just throw the error. If I say right row F dot F, I think this is going to throw an error. It might try to do something. Okay, yeah. It expected an iterable. Iterable means something we can walk through. So something that's just in there to set. Set is our most basic collection. List is the one we would use most often. Could be a dictionary. Could be any number of things. Lots and lots of things, right? There's lots of things we could send there, but something that has indexing might be a way to say it. If we can ask for the stuff via index, well, actually, that's probably not the way to say it because a set would work. And a set doesn't have indexing. A set just sets are for when we need the whole collection every time. And an index would just be a little bit of overhead there. But to make that person enter a list, I'm going to add in some square brackets. Sorry, let me zoom in there. That was kind of small. Can you see that better?
Oh, yeah.
I always forget to zoom in on the side I can zoom in on. I need to go change the font size. Will probably be the best thing to do. So now I can say like F dot name, F dot age, and F dot count. So we're sending it a lit. We're sending it that person data in the form of a list each time. That works. So if I run that, no output here, no output in our console, but over here in this folder, we now have a CSV file. And that one's easily spotted because we get, well, I guess I must have Excel on the machine. Because the Excel icon shows up and spreadsheets grew out of CSV. They just put some nice graphics on that separation. We get boxes instead of commas there. Oh, I must not be signed on. Okay. I changed that to one that I use, but highly, highly organized. I often like to use these CSV files as we're looking at here. Let me open it as a text file. Close this. We don't need all the Excel buttons. Open with Sublime. So this is what the CSV file literally looks like. Those data points with a little quote in there. And if any spaces showed up or if any commas showed up, it would wrap it in quote marks, a string. So the library knows how to deal with that. Right? Sometimes our data is going to have commas in it. So we could type it ourselves. It's just the text with a comma. But whenever we hit those special cases, we need to worry about putting it in quotation marks to indicate that whole string goes together. And especially with commas in the data points, that comma is not a separator. It's not the delimiter, it's the thing. Notice it gave us, this library gave us extra rows. We'll see that when we bring that back in. That's not too bad of a thing to deal with. But this form right here, when we pickle the data, the way pickling is set up, it basically puts it in this form. So a lot of times when first building a piece of software and debugging it, I'll use the CSV writer to see what's happening. And then when it all works, then I'll switch to the pickling. Because the way it's set up, it basically does this in binary. Not text compatible binary, but Python binary. So it's closest to looking like this. So I find it helpful for debugging. Close that, close that. And to read it, it's very similar. We'll open a file handler. So with open data file 3.csv in read mode as I'm going to go back to to file and from file because that's going to confuse me. I guess changing it real quick can help you see which ones we named and which ones came from the library. Yep, I believe everything except that one I just changed. That's the only word there I can change. Everything else is a keyword or except the name of the file. So to file and from file. I just think that looks better in an example, right? Oh, when we wrote it, we created that CSV writer object. Anybody have a guess on what we need, what object we need in order to read it? I see your mouth moving, Tiff. Did you say something?
Is it RB? Wait, I know you do.
Oh, we need that. So I was looking at this line. So we said writer is CSV writer.
What was it? CSV reader from file?
Yep. Reader equals CSV dot
Reader, parentheses from file.
Yep. Exactly. And the handler already knows which file it's looking at from the open method. It also knows it's open-ended as a read handler. So we have all that stuff, and then we can go through it. There's my example. I'll just print it out for row in reader. Print row.
Are we getting this is the information we're getting back?
What's that?
Is this the information that so do we not put an RB right up there?
Oh, it's not a binary file. RB
Okay.
is binary.
Reading binary, okay.
Yes. So it's human readable. Right? See, we just opened it and we were able to read all that, right? So that's just a regular read.
That's because we pickled the other stuff, okay.
Yes. I think we need an RB coming up in a moment. Jason's right. And Jason doesn't. When we get to the XML handler I chose, there are lots of XML libraries built into Python immediately. When we get to the one I chose, I think it's easiest to work with. It requires us to write binary, even though it is still human readable. But text is only one format for looking at an XML file. The data, it can be separated from the way we view it. So for CSV and JSON, it really is text. But for an XML file, we can view it as text. Text is one of the options on how we view it. But again, JSON is, you're going to use JSON in the modern world. If you know for certain you're going to C++ code, then XML will be superior, or Java. But it's very rare that you would be processing it in Java on the other side and not writing in Java on this side. It'd be more likely that we're writing in Python and process on C++ or C# on the other side. If you're doing that, XML would be better, but JSON will still work. You're going to use JSON over and over and over again. As long as you understand the differences between them make sense. Yeah, so when I read it, there's the first one brought back in. So we probably want to go through and turn that back into object for processing. I'm just going to print it out here. Y'all know what to do from there, right? We get it back as a list. And once it's a list, throw it back in the constructor for an object to work with. Throw it back in the original list. There's different things we could do, but we'd have to do something with that list. But we also have all these extra ones. Those empty ones would cause a problem, right? So make sure you do something like, well, you can put an index in your for loop and then only use the even numbers, right? So we can see right here, it's 0, 2, 4, 6, and 8. And 1, 3, 5, 7, and 9 are the emptier list. So only use the even numbers, or they're empty lists. So we could say if length of row does not equal 0, then print it. So if the length is longer than 0, print it. We'll never have a negative length. I guess I could put greater than 0, but not equal was the one that popped in my mind. And that'll filter down to just those data. So just, yeah, there's multiple ways to grab it. And once you have the data back, you all know what to do with the data once it's here.
Is this something you could use on a post method? Like if you wanted to set up auto responses for a client that got like emails and you wanted to store that dot automatically and send responses?
You could do that. Yes, that's what the API is doing.
Okay,
That's what we look at after a break. That's what an API is, because application programming interface. We talk about interfaces, right? How we connect stuff. We're making a piece of software. How do we connect to our software? The term rules often shows up because we're talking about the instructions we put in, but application programming. So our program is the AP, and then the interface. So if you think of the physical plugs like a USB port, what is the shape of what is the shape necessary to plug into our software here in case somebody else wants our data? That's what an API is. And that's where the post and get will come in useful. I almost never delete. We have delete. I believe both videos showed delete from the CRUD. But personally, if on the client side, you go ahead and click that delete button, what I do is use that to notify the server administrator to delete that. Send an email to the database administrator to delete that, not just automatically delete it from the table, if that makes sense. That's just the way I prefer.
they need to find out, that way there's a history.
Yes, because I've done that because I've accidentally entered an infinite loop with the delete command. It's like, whoop, you need to make sure that never happens again. Or you get into malicious stuff, malicious intent. If they can't actually delete things from your database, all they can do is notify the database, send an email to the database administrator. Hey, can you delete this record? It's a lot. There's an intelligent creature along the way. That's how I handle delete. There is an instruction for it though, but that's getting into something different. So that's the CSV file. Send our data to the file and bring it back into our program. And for sending it elsewhere, we'll see the post and get and request and response. And then the other parts of the CRUD model after the break. We'll look at post and get, or the request and response, and that'll get you all a good start on it, because we are very restricted on time. We just want to know this stuff exists and get a little basic practice. That way, if we see it in a professional setting, it's not the first time we've ever seen it. We're always going to look stuff up, right? Because between now and then, there's a pretty good chance something that's commonly used as an API, somebody's going to make some improvements along the way. People are going to write more libraries to handle APIs between now and when you need that in a professional setting. So there's always going to be that looking up, right? If we did it last week, that doesn't mean somebody didn't write a module since last week, or they didn't hit the publish button on this GitHub repository they've been working on for 5 years to get as a better way to do it than what we did last week. So there's always going to be looking stuff up, because you want to use if somebody wrote a better method, you want to use that. So now JSON, this is the one you're probably going to use. Import JSON. Pretty sure y'all could have guessed that one. This is storage. So this would come in handy in an API. If you know our program is just a small script running on a server, and all it does is grab the JSON file and send it to the client, then the perfect form to store it is that JSON file, because then we don't have to do anything else. We're just our server becomes a bus. We're just somewhere in that like a wire between the storage and the client, just part of the wire. So we might as well store it that way. So once again, like always, we need to open a file. With open, I'm not feeling very creative. So I guess we're only up to data file 4.json. Your text editors will recognize that, so you get some color coding. I'll be opening a Sublime, which barely recognizes it. Sublime does their settings in that, but because of that, they decided to keep it just one color, because it would I think it was version 1, maybe into version 2, they had a bunch of colors there, and it was just overwhelming in the settings. So they went back to they only show one color of JSON. But other text editors that don't directly use JSON inside of them they they will show color changing like you're used to. So that'd be the extension for that. We're going to write it because it counts as human readable. What it is JSON JavaScript object notation. So it is one of the ways we can create a JavaScript object. It's writing JavaScript code. It's a nice, concise way to write JavaScript code. It's really hard to do inheritance with JSON, but if you're going to create data objects and then use them immediately, it's great. It's much easier than the function format of creating that. Again, I'll call this toFile and from file. And for F in folks, all of that you probably could have guessed so far, right? Probably would have guessed that the library was called JSON. Create a file handler, and the standard way to create a file handler in Python, loop through our data. And now what do we do? I'm gonna call that handler. So this time it goes the other way. So toFile.write. This is what you would have seen in the previous class, right? You open the file handler, probably a different notation in the 140 class. You'd say toFile equals open data file 4.json in write mode. And then on the next line, you do toFile.write. And then you need to come back and wrap that in some exception handling because there's issues that could happen and little things like that. So a different format than you might have seen in the previous class, but this is the one you've seen before. And now we put in text. And to handle that text, we want to use the JSON library, json.dumps. And dump. We can dump or dumps. Use the plural one. Notice dump, object ensure, ASCII, check circular. Notice they have different parameters. So you want the one with the S. So that just writes to a file. And then we have to set up the keys. Because right now our data is a list of these objects. If we had a dictionary, it would go more directly. If we had it as a dictionary, we could just pass the dictionary in here and that'd be fine. But a dictionary has the keys, right? So instead of numbers to index that list, we use words. We don't have those, so we need to go ahead and add those in here. So we'll have a name attribute that gets f.name, comma, age that gets f.age, put a space there for readability, and a space here for readability. And then we need the town, which gets f.town. What am I missing? Oh, sorry. Put your curly braces in like it's a dictionary. We have to turn it into a dictionary. I think I said that, didn't I?
How did you know something was missing? What did it?
Oh,
Oh, okay, sorry.
There would have been another error message if we tried to run it, but the IDE put a little red X over there to say there's something was wrong with that line. So some curly braces to turn that into a dictionary. So if you already have your data as a Python dictionary, it can go directly to a JSON thing. Actually, if it's a Python dictionary that only has data points like this with strings and numbers, you could just write it there. But if you had functions, it wouldn't. You need this if you have functions that you want to send. you have Python functions, and you want to turn them into JavaScript functions. Because that's what a Python dictionary and a JSON object would look identical next to each other until we got to how they handle functions, because they handle functions differently. But we're mostly talking about data transfer tonight, so that doesn't even matter on us. But this would be the proper way to do it. And there's some other stuff in the background that keeps it a step above text. So it's better to do it that way all in all. Anyway, run that. And it's in write, not append mode on all of these. Obviously, we have append. We can use append instead of write and keep adding data. But there's going to be a whole bunch of runs, so we don't necessarily need to keep adding data to that file in tonight's class example. We can just overwrite it. So stuff's the same up through there, but we now have this JSON file. Everybody's using Notepad++. It has great colors for JSON. What else do I? Yeah, my only option is Sublime, which it'll turn numbers different colors. Notice there's no line breaks or anything. Line breaks are for human readability. If you want to do that, it is perfectly okay. I usually prefer to. So after our dictionary here, so JSON.dumps takes in a dictionary, turns it into text, and then we can add a line feed afterwards. So everybody see that where that goes with respect to the curly braces and parentheses and all that other stuff in that line. Add a line feed, and then that'll make it look a little bit better. It's still not in pretty print. That is the actual term for it. When we start putting line breaks and indents in indentation, the term for that is called pretty print. The XML library we're going to look at does not have a pretty print option, so it only does one straight line. That stuff's really easy to write. You just need to count how many times to indent and then throw in some line breaks, and it's usually done in a loop. So you just use your index from the loop to do that many tabs over. \T for the tab and \N for the line feed. But it's still the JSON format there. It's just in one line here. And we have that whole big file. That's the way you're probably going to send it. So it doesn't hurt to store it that way. Especially when your Python script isn't doing anything but grabbing that data and sending it right across the internet. It's already in the format we need it. Reading's just as easy. With open data file 4.json. Y'all can probably guess most of this by this point, right? As from file for line in from file print JSON.loads with an S. So we have dump and
Why
dump.
line? Why line for line in from file?
Because our file is a bunch of lines.
Okay.
Still open? Let me open it real quick. Because we have a bunch of lines.
Mm-hmm.
Like a sequential data.
Why not row like the last time?
You can use row.
Okay.
That was just part of the, yeah, you can use I would probably be the most common thing to use there, right?
As long as you use the print statement.
Yes.
Yeah.
Yeah, as long as, yeah. So just like when up here where I say F in folks, each element in that list becomes this. The for loop in Python is what we call for each elsewhere. Remember, we had a bunch of those in PHP class, Steve. The for each loops that were different than our for loops. And it automatically splits up what we have. So the list automatically splits up in elements of the list. A file most naturally splits up into lines in a file. What else can we split? There's different options, but it automatically splits it up into whatever is most natural for the thing, for the collection we're reading. We'll talk about data structure soon. So make sure you use, as far as dump and dumps and load and loads, use the one with the S. Which, if it helps, we're almost always doing in for loops because we have more than one data point. Otherwise, we wouldn't bother to save one data point. That seems a little unnecessary. So we're always going to do it in a loop. So just think plural, if that helps to remember it. And then something to remove the white space, line.strip works. Line dot, we can index it and start at line. The line feeds at the beginning, so we'll go from the index 0 to -1. We'll just stop one character before the end because a string is always an array of characters. So we can treat it that way. Or we have the dot strips method, because I don't think we've used that. I don't think that one showed up in your homework assignment last week. So that's why I decided to throw that one in there instead. Normally I would do the indexing because that's what we have everywhere in every programming language. So we don't really have to stop and try to figure out what we have. A string is always an array of characters. We don't have to try to remember special methods, but that's a very useful one that was not in last week's method, or not last week's homework assignment. There's lots of string methods. Make sure you check the official documentation for Python strings. There are some very, very useful ones in there you might use. And that's the two we need to store that data, right? Nothing too fancy there. Any questions about that? Notice, if I zoom back out. Anybody see much difference in our part? The only thing we did different is it's basically which library we imported.
Yeah, and we just reversed the to file and that putting down first.
We had to do that. We had to open a file handler for reading and have a file handler for writing both times. We had to loop through our data. The only difference, well, we imported different modules, and in CSV we had to turn objects into lists, and in JSON we had to turn objects into dictionaries. That's the only difference, which otherwise we did the same thing there. I guess there's less typing involved in turning it into a list. I'm going to throw out the XML one. It's fairly, it'll be quick. I want to add some data to these because with markup language, has everybody had the HTML class, SDEV 153, or seen markup languages somewhere? So we have attributes in those tags as well. It's not just the tags, we need attributes. So I want to add attributes. So what I did in the when preparing, I was thinking just nicknames will make a good attribute. It's not actually part of our data, but if we have it from somewhere else, not in our database, we could use that. So I'll say nicknames. And I'll just create a list and do parallel arrays. So index 1, Sally, index 2, or index 0, Sally, index 2's Charlie, Corey, and then the same index refers to the same one so that we can keep those straight. So Sally, I guess, can be Sal. Charlie's Chuck. I don't know, Beanstalk. That seems like a nickname somebody might have. How many was it? 1, 2, 3, 4, 5. Or this guy's double L for some reason. And what else? Jeff. Big J. So some nicknames, but I just did that so we'll just show you how to do the attribute thing. our data goes in tags, so we need something to look at the syntax for the attribute when we do this. So there's different ones we can use. Import xml.etree.elementtree. This one's quite easy to use, quite easy to get started with. My personal favorite is Sax. That's an outside one that we will find Sax parsers in every single one of our language because it's an independent company that made a library for doing it that does it in assembly language, and they just connected it back to whatever text file we're creating. So C, C#, C++, Java will always have a Sax parser. That's my preferred one, and then it's the same everywhere. But this one is actually part of the Python language. So we should probably look at the one that's actually part of Python language. Whoops, element tree. Oh, I should zoom back in. So XML, and remember this is a folder path. This is a directory path in object-oriented notation. So normally we would see that as the XML folder / etree folder / element tree file. But we're actually coding here, so we need the object notation of the directories and files, not the navigating notation for the directories and files. That's why it's so deep. But that's a lot to type. Definitely don't want to type that every time. So I'm going to do as et. That seems like a lot easier to type. Which, has everybody seen that before? When we import a module, we can just rename it into something that'll be easier to type. So it's a tree. That's another thing. We're going to talk about data structures too. Another thing about XML, the times that you might want to use that. Since neither of the videos that I put on there were very clear about when we would. They both mentioned that you might still see XML, but they didn't say why you might still see it. It's a tree. When we talk about data structures, we will spend a lot of time on trees. We will talk about lots of different types of trees. Every time I draw those stack heap diagrams, a heap is a very special kind of tree. Trees are very, very important. A directory structure is a tree. Trees show up everywhere in computing. So XML is a tree, which that would be another time when you would want to use it, because we don't need to read the whole file. With our JSON object, is that still open? If I wanted Jeffrey's town, I have to start here at the beginning and go through all of this until I get here. And then I'm ready to read in the data point I actually wanted. If there's a tree, that almost looks like a heap. Let me scatter that up so that we have something a little bit messier. So if there's a tree, our restriction is we have to start here.
Is it possible
But
to
I don't
zoom
need
in?
every single data point between here and here. There's different ways. I can go this way and get right to that data point with only reading 4 of them. That would be the other reason to use XML, but that's not going to make much sense until we get to the trees. No one's seen that, I know. What I do there? Left, right. I guess left, right, no. So postfix, be a nice quick way to read the tree. But we can jump to any of these points really, really quickly. We don't need our whole data set. If it was perfectly balanced tree, like if I had another node here. Oh, that is balanced. If it was that, we could jump right to any one of them. Really, really quick, because that would be a heap, which is sort of our best data structure, but we'll see data structures soon. That would be the other advantage of XML. And I know it's time for a break, but this one's gonna go really, really quick, especially since it's not gonna be used as much and it's gonna be random. It's not gonna be used as much JSON, so it's gonna be random enough. You're probably gonna look it up. So I want to make sure we do at least one pass. That way you've seen it before. But it should go really quick and then we'll take a break. ET. Or is there anybody that do we need to take a break now? Anybody having trouble waiting for 5 more minutes? 12 lines of code and not much talking because 10 of those lines are just a slight modification on the previous of the same thing. So it'll be real quick. We'll get breaks. Nobody's saying, yeah, they need to go now. So root is going to be that ET library that we imported, and we'll create an element and give it some sort of name, basically the tag name. This is going to be people. That's our type of data, right? That's the overall root, and then each individual person will go inside of the people tree. Now that we have that, we can just walk through here. So for, I'll do 2 things. I'll do count and F in enumerate folks. We haven't seen 2 things in the for loop yet, have we? I guess that's something new. So this is a nice way to get both the index and the element. We can do multiple things, and this is enumerate method. We'll just count the items in that list one at a time. So the first time we go through it, it gives us a 0 and count, and element 0 in that list is called F. And the second time it gives us a 1, and element number 1 is called F. So we don't need the index, but we have both of them. We haven't seen that, and I threw it in the example, so might as well see it. Multiple things in the for loop is a little confusing at first. Make it a point to try and do that sometimes. So X for X comma Y in range 12 comma 6. See what that gives you. That would be an abbreviation of nested for loops that you of a type you've probably used before. So it's always a little confusing at first. So I guess the main thing is know that you can do that. If you need both the element and the index, but you don't want to use the index for the elements, that method right there is a really good way to get that. Now we can make a branch from our root. So each pass through gets its own little branch, and that'll be et dot sub element with a capital S and a lowercase t. Sub element, and then it needs at least 2 things. First off is what is the parent? What parent is it attaching to? Well, we're going to attach it to the root parent, and this will be a person. So if I draw a picture, the video might be small here, but I'll draw it big. So we have our root. You don't see that on the video, Tiff? You're usually watching on a small screen, right? I'll stop sharing in a second. So we have made a root and we added a branch to that root. We're building up our tree this way. I'm gonna stop the share. We created the root, added a branch to that root. But we have more than just that one branch. Oh, whoops, wrong button. Share screen, go back in here. Now we have some particular data that we can add to that tree, which we'll talk about trees soon. We'll spend a lot of time when we talk about data structures starting next week. Leaf, we can add leaves to that. So like leaf 1, I'll call it that, is another et dot sub element. And it's going to attach to branch. And this one will be for name, I suppose. That sounds good. Leaf 1 dot text. The actual value we want to store is going to be f dot name. right? So everybody that responded said they've seen HTML. And so leaf one is a variable referring to our opening tag. And then in between the opening and closing tag, we get some text. So leaf one dot text, which is where we put our actual data we want to store. Leaf one dot attribute. Oh, it's abbreviated, is it? Attrib. That's one I always have to double check because it's not abbreviated the same way I would have abbreviated attribute. I would have probably stopped at ATT and been confident that any programmer that looked at it knew what ATT stood for in the case of markup languages. And that will be the nicknames. We want to send in as a dictionary, nickname gets the value nicknames list, whatever index we're currently on. That's why I grabbed both of them that way. And it seemed like a good place to see that for the first time. Really be aware that that is possible and do some random trial and error and see if you can play around with it and make more sense of it. Because that's it. I know it's confusing. And when I talk about it, it might all make sense. And then when you go to do it, it's not going to make sense. So that's when you definitely want to play around with. My suggestion is do like X, Y, and then do 2 range functions to start with. Make little adjustments to see what else you got. Then we can do some other stuff for leaf 2 is et.subelement, which again attaches to branch. And this one will be the age. And leaf 2.text is f.age. Leaf 3 is another et.subelement. Capital S, lowercase e, that one is also something named differently than I would have named it. That's the reason I usually don't use this one and go back to the sax parser, but SAX. Simple something XML is what it stands for. I can't remember what the A stands for. What's the left? Town. To that branch, we want to attach a town node. And leaf 3.text is f.town. So that would build up our for loop. So then over here on the tree, doesn't have to be a binary tree. We just attach, well, I guess really, yeah. Here's our branch. And then we attach 3 leaves to that branch for name, which also has the nickname. I'll abbreviate it there, attribute, age, and town. So XML is a tree. We will talk about trees at length. That is another time we might want to use that. But again, in the modern world, most people go with easy. So until your data set gets pretty big, easy is good to go. And when your data set gets massive, there's something else we're going to look at here in just a moment. It's like 2 more lines to type. But it builds a tree, and we'll talk about trees soon, why we want to use those. So we have all those pieces because it's going to do that over and over again for every branch, right? We loop through and put all of our stuff on a different branch, and then we'll tie those together into a tree. And that is going to be et, so the library.element tree that takes in the root. And then all that other stuff is connected to the root, so it's going to come along with it. And now we can write it to a file with open data file. What are we up to? 5.xml for write mode as to file. Tree.write. And then pass in the handler. So all the stuff to write all that stuff, write that in a file, that's it. Isn't that a lot easier? Does that look easier than writing all those tags? You might remember the HTML class. The reason software developers all have to take that is because eventually you're going to make something. You're expected to write code like this that would write HTML tags like that for artists. But we kind of have to be familiar with it before we can make that stuff. Or we could use this and explicitly put these names as it known HTML tags, and then this library we just write that HTML depending on how an artist drags the mouse around. A really easy modification there. I guess I'll go ahead and read it in. So new tree dot new tree equals et dot parse. Is that what I want? Yes. Data file 5 dot. Since it's an XML file. Oh, whoops, I did forget something. When we write it, it does need to be right binary. We'll be able to read it, but markup language XML technically isn't a text file. It is available in text format. So we have to write binary. It's a tree. When we use markup languages are a tree. They just happen to have a text formatted option. So we need to parse. So instead of creating a new one, we'll just parse the one that's in the file. So that's still an element tree object. Automatically return that. And then we can just kind of loop through it. We need to figure out what the root is first though. So where do we start at? So new root is going to be new tree dot get root. Is it all lowercase? Yes, all lowercase. New tree. They were inconsistent when they named it. Typical for Python. So we parse the tree from the text file instead of making a new object here. It's going to create the object as it reads through the XML file. Then we just need to figure out what the root is on it. And then for what I put in my example, I in range length of new root. There's different ways we can do it, but that looks a lot like how we would get all the way through a list, right? We need to come down, we need the numbers for it, basically. And the reason why is we need to nest loops for J in range length of new root I. Because each one of these branches could be different, right? Ours is consistent, everyone's going to have 3 leaves. But not every element in that XML file is going to have 3 leaves on it, 3 leaves on that tree. Every branch can be different. So we do explicitly need the numbers here to get through that. That enumerate method I showed earlier would work as well. That enumerate is like range of length of. It just combines it into one thing. Kind of nice word. Then I guess I'll print it. Print new root I j dot tag plus a little spacer there and new root I j dot text. And then this closing parentheses that I somehow got my cursor in the wrong spot for. Supposed to have. Oh, and then I also did this print new root dot attribute, which again is very different than I would have done it, and I forgot the I and the J. So there's the syntax for XML. It's all built in. It seems like a lot here, but the data sets can get very large very quickly, right? And when we talk about trees, you'll see the advantage of just having it as a tree. Uh-oh. String object has no attribute strips.
Yeah, I noticed that earlier.
So it's strip. What did I spell wrong there? Sorry, it was strip, not strips. Strip the stuff off. It should make sense in an English sentence, right? Strip the white space off the line. And oh, I missed the T. So element tree in camel case. So there is two trees, two T's there. Let's see if that got all. Yeah, that goes away. Module XML element tree has no attribute sub element. And I just completely misread my example. It is an E on every single one of those. So I'm going to hit Control R to get the find and replace and do sub element and replace all of those so as I get the zoom stuff out of the way. The zoom buttons aren't going away. There we go. Replace all. There we go. So Pascal case on sub element. I was looking right at the example. I could have swore I had a lowercase e, but there's a lot of e's in that word. So I might have just looked at the wrong one while I was talking. Cannot serialize. Which line did that happen on? Well, we know what it is. Right? Age is the only number in our data set. And you'll know it looks different, but the same error message you're used to. We turned it to a string. We need the text. What? Oh, that's not the one. Sorry. That's not the one we want to change. In JSON, we can send an integer. This one right here. F.age needs to be a string to go into the text file or the text variable. There we go. You can see we got all those back, got that information out. Some of them don't have any extra attributes, but we got name, age, town, and it's a way we can parse through it. Be more useful when we talk about trees. We'll see trees soon. Basically, just remember it's a tree. You might see the format. This will create all those XML tags, or it's not hard. It's not hard to write a function that adds XML tags in manually and does indenting. It does not come in pretty print. Where's the XML file? Oh, definitely don't open with Edge. Open with Sublime. So word wrap's on, but if I turn word wrap off, it just gives us one big long line of XML stuff. I don't know what Edge is going to do, but if I open it with Chrome, why is Chrome not an option?
Can you use that line break on there to put them on separate lines?
Yes, browsers do have pretty print. Edge would have done that, but I think Microsoft went and updated some stuff. There was a message earlier from OneDrive, and I went in and manually disconnected all the connections to one. I went to the registry and disconnected my computer from OneDrive. So there was no connection to OneDrive whatsoever, and a few things seem to have gone back. So an update must have adjusted that. The markup language file, we can see it that way.
That looks familiar.
They have advantages, but in the modern world, easy also has an advantage. So we're most often going to see Python and JSON. because they're easy. That's what we want to go with. But that took 20 minutes longer than I thought it was going to take to get through those things. Good time for a break, right? Does anybody have any questions about those? All right, so let's take 10 minutes. My clock on laptop says 7:35. So we will get back to it at 7:45 and look at APIs.
Scroll all the way down.
Yes.
I want to see the last couple things. New route. And change like that. Thank you.
And I gotta find the stop recording button with the video there. Stop recording, there it is.